Hello good people, I'm going to talk about linear relationships. A linear relationship is a relationship between two variables that gives a straight line when plotted. It can be expressed by the general equation for a straight line, which is y equals mx plus c. What do all of these terms mean? Y is the dependent variable that we are going to plot on the y-axis. X represents the independent variable on the x-axis. M is the gradient, also known as the slope or the rate of the line. And C represents the y-intercept. It indicates where our line will cross the y-axis. There are a couple of things that need to be unpacked here, especially this innocent-looking equation, y equals mx plus c. Let me bring in an example. Back in the old country, when I was young and a devilishly handsome lad, I used to get an allowance. The amount I received depended on the number of chores I performed, such as herding miniature space goats. That being said, I was very fortunate, because even if I performed 0 chores, I could still count on 50 credits. From then on, I received extra 10 credits for every chore I performed. So if I performed 1 chore, I would end up with 60 credits. If I performed 2, I would get 70, and so on. The information in this table that shows the relationship between the number of chores and the number of credits I received can be plotted. What goes on what axis? Well, considering that the number of credits depends on how many chores I perform, it means that the number of credits is the dependent variable that will go on the y-axis, and the number of chores is the independent variable that will go on the x-axis. Now that I have my axes, the ordered pairs in the table become coordinates that I can plot. So at 0 chores, I will receive 50 credits. So that would be the point at 0, 50. Here it is. If I perform 1 chore, I will end up with 60 credits. So that is this point here at 160. If I performed 2 chores, I will end up with 70 credits. So that would be this point here, 270, and so on. Now that I have my points, I can connect them with a line. Lo and behold, I have ended up with a straight line, which means the relationship between number of chores and the number of credits I receive is a linear relationship. It turns out that each straight line can be described by an equation, and the general equation for any straight line is this y equals mx plus c. The two variables that are of particular interest to us are this m, the gradient, and the c, the y-intercept. What are the gradient and the y-intercept for this red line? Well, the y-intercept is relatively easy to read. Our line hits the y-axis at 50. Great, we already have the value for the y-intercept. Now we need to determine the gradient. The gradient gives the change in the y value as the x value changes by 1. We are interested in how much does the y rise as the x runs along. And because of that, the gradient is often described as rise over run. In this particular case, I could say that for each extra chore, I get 10 credits. As I rise by 10, I need to run 1 along. Or mathematically, I could say that I will have 10 credits per 1 chore. And 10 divided by 1 will give me 10. This is the gradient of the line. This is the rate. 10 credits per single chore. Now that I have both the y-intercept and the gradient, I can write the equation for this red line. Y equals 10 multiplied by x plus 50. We went from a general equation for any straight line to the equation for this particular straight line. One way to think about this equation is as though it were the name for this line. To test that the equation is working correctly, I'm going to pick one x value from the table, let's say 3, and see if I get the corresponding y value. I'm going to say let x equal 3 and then see what happens to the y value. I will have y equals 10 multiplied by 3 plus 50. 10 multiplied by 3 is 30, plus 50 will give me 80. Beautiful. That is exactly what we had in the table, which means this equation is correct for this line. Now, as it happens, I have a brother, and he too would receive an allowance. He was a little bit lazy and needed to be incentivized. As such, if he did nothing at all, he could only count on 10 credits. However, for each chore he performed, he would receive an extra 20 credits, which means if he performed a single chore, he would end up with 30 credits. If he performed 2 chores, he would end up with 50, and so on. If I was to plot the relationship between the number of credits my brother received and the number of chores he performed, it would look something like this. At 0 chores, he would end up with 10 credits, so that is this point here at 0,10. With 1 chore, he would end up with 30 credits, so that would be this point here at 130. With 2 chores, he would end up with 50 credits, so this point here at 250, and so on. These points can be connected by a line too. What is the equation for this blue straight line? What is its gradient and what is its y-intercept? The y-intercept is relatively easy to read, and it appears to be 10. What about the gradient? Well, in this case, the rate, or the slope, or the gradient, is 20 credits per chore. 20 divided by 1 will give me 20. That is the gradient of this blue line. Now I could say that this blue line can be described by the equation y equals 20x plus 10. Note that the general format is still y equals mx plus c. As before, I'm quickly going to check that this equation actually works. And this time I'm going to say let x equal 4 and see what happens. This will mean y equals 20 multiplied by 4 plus 10. 20 multiplied by 4 is 80, plus 10 will give me 90, which corresponds with the data in the table. And this in turn means that this equation is correct. In summary, a linear relationship will result in a straight line, and a straight line can be described by the general equation y equals mx plus c, where m represents the gradient, the slope, or the rate of the line, while c represents the point where our line crosses the y-axis. That is all for now, and I will see you on the flip side.